Okay, so the first thing I need you to do is on the back of the full sheet of notes, looks like homework, right? Put a big X on it, because I turned it in wrong. They're both one-sided, and I accidentally said put it on both sides. So I'm going to give you another sheet that looks just like that. I just don't want you to accidentally do it on the back of your notes and then be mad that it's on the back of your notes. Does that make sense? So just put a big X on it. You'll get another one once we're done, and then that's just there. I didn't want to waste more paper because it's not that big of a deal that it's there. All right, but we're going to start by looking at this one. This is going to go on page 101 when we are done. So we created the sine graph and the cosine graph, and we've graphed those already. We did not create a tangent graph. We could do it from the unit circle. It would be a little bit more tricky to get those measurements, but it's definitely possible. We're just not going to do that. Instead, we're going to take what we already know about tangent and graph what we can and see if we can figure out what it looks like. So raise your hand if you've seen tangent graph before, like you know what it looks like. Okay. Good. That's what I was hoping for. And that's what I expected. I don't expect you to know. So I want to show you that even though you really don't know, we can figure it out. So parent function, f of x equals tangent x. And remember, you can only take tangent of an angle measure. So your input, which is x, has to be an angle measure. Your output is the tangent of that angle measure. Okay. So what is the tangent of 0? It's 0. Because you're at 1, 0, so it'd be 0 over 1. Okay, so it's 0. All right. So then, what is this x value right here? The x value. Pi fourths, right? Because this is pi, so this is pi halves, this is pi fourths, right? So what is the tangent of pi fourths? 1. Okay, so at pi fourths, I'm at 1. Okay, so what then is the tangent of pi halves? Undefined. So how can we represent undefined on a graph? Okay, could be an open circle, and I heard that last period too, and that is a correct statement. That would be undefined at that point. The holes though come in when we have rationals and we're canceling stuff out, right? And so that is a true statement. You were correct about that, but that's not how we got that in undefined, right? So we can't use the open circle. What's our other way? What? I'm sorry. Dotted line. What's a dotted line? An asymptote. Okay, so at pi halves, it's undefined, so we're going to draw in an asymptote here. Okay. All right, so then, that's pi halves. What's this x value? 3 pi fourths. What is the tangent of 3 pi fourths? It's pi fourths, so it's going to be a 1, and what... 3 pi fourths is in which quadrant of the unit circle? The second. And is tangent positive or negative? Negative. So it's a -1. So you still need to be able to visualize the unit circle, knowing that it's different than this, but that's still where you're going to get your stuff from. What is the tangent of pi? 0. Tangent of pi is 0. So while we're doing this, still picture yourself going around the unit circle, because remember, this just unrolled from the unit circle, right? What is this x value? 5 pi fourths, which puts me in the third quadrant of the unit circle, right? And what's the tangent of 5 pi fourths? 1, positive 1. Then what is this x value? What's the x value? 3 pi halves, right? 3 pi halves. And so this is 3 pi, this is 5 pi fourths, right? So this makes it 6 pi fourths, but it's 3 pi halves. And what's the tangent of 3 pi halves? Undefined. That means we have an asymptote there. What is this x value? 7 pi fourths, and the tangent of 7 pi fourths is -1. Okay. What is the tangent of 2 pi? 0. What is this x value? Now each one's a pi fourth, so this would be how many pi fourths? 8, so this is 9 pi fourths, which puts me back in the first quadrant though, right? Even though I'm in the first quadrant, I've rotated once to get there, so this x value is actually 9 pi fourths, but what's the tangent of that? 1, back to 1. Okay. So even though you didn't know what this looked like before we started, just plotting the pi-fourths angles and pi-halves through just one rotation plus a little bit, do you get an idea of what the graph looks like? Yes. Could we continue this on the left side? Yes, because we have something every pi-fourths. So I was here, I have an asymptote, then I'm at 1, 0, so this will be at -1. Yep. And then I'm going to have an asymptote, and then I'm at +1, 0, -1. I'm at +1, 0, -1. Okay. All right, so then we have to actually sketch this thing in. Clearly, this is not going to be a line, even though I could like just draw a line through these, it can't be a line because then it would poke through the asymptote, and that's a no-no. So it has the look of a cubic. It's not a cubic, but it has that look because it has a point of inflection. I know some of you have a difficult time trying to get that curve in there, and I see weird, like, squiggly things for you trying to make it. Don't make it harder than it is. If you think about it in two pieces, it makes it a little bit easier. I mean, I usually do it in one thing, but when I'm doing this one right here, if you think about this kind of as, it's not really half of a quadratic, but you see how it curves in like this? And then this would be like half of a quadratic going the other way. And so that you're not trying to do a squiggly right there at the point. And that's where I think it's throwing some of you off, because it's bumping out the wrong way. So, and then you get frustrated with the graph. And once you get the hang of it, it kind of makes a little bit more sense to you, then it's a little easier to do. So make sure all of these little pieces have arrows on them. That is important. I'm not making you draw the arrows on the asymptotes, but on the rest of them, they need to be there. Okay? I will take off points if it's not. Depending on the mood I'm in, I might count the whole thing wrong. Okay? Just saying. Depends on how irritated I am by everybody's graphs when I'm great. All right, are we all good? So there is your tangent graph. It is not a sinusoidal function, right? Because the sinusoid is any translation of the sine, and this clearly is not the same as the sine graph. It is, however, a periodic function because it does repeat, right? It's definitely very repetitive. So let's look at these things in this first set of boxes over here. Domain. What would we say the domain is here? What are you thinking? Thinking it's kind of hard to say? Yes, okay? Because there's a lot of things it is, and there's a lot of things it isn't, right? But it's not like I can actually list it out. But the things where I can't have x values, are they pretty consistent? Yes, okay? And so we can write the domain in a kind of a way that we wrote our zeros the other day. I'm going to say that it's all real numbers, except that x cannot equal some things, okay? So we can't have x values where our asymptotes are. How often do the asymptotes happen? Every pi, right? But it doesn't start at 0, so I can't say n times pi, right? I got to move it over a little bit. So it cannot equal pi halves plus n times pi. And that's moves that over there, right? But n has to be what kind of number? An integer. It can't be 0.5, right? I have to say that it's an integer. So then I put a comma and I say where n, and I'm not sure that I didn't really explain the element symbol to you. I'm not sure. But it's like kind of a flat C with a line in it. And so I know sometimes you can't tell if my handwriting is just bad or if it's like a symbol. That really means is an element of. So n is an element of the integers, and the integers is that weird z. Now, we're going to have some more of this notation, but here's what I want to make sure you understand about this. I'm not going to make you rewrite this. I'm not going to ask you the domain 1,000 times and expect you to have all this. I don't want this part stressing you out, okay? Because this is not the super important part of what we're doing. It is important that you can understand it. Like when we talk about it, you're like, okay, yeah, that makes sense, right? But don't stress out over, I'm not going to know how to redo it or whatever. Michael, put it away or I'm going to take it. Put it in that box right now. Anyway, I don't want this stressing you out. It should make sense to you right now. We write it down. Ask me questions. Just put it in the box before I take it anyway. And just make sure it makes sense. Are we good? Okay. All right. So then the range. What do you think the range is here? All real numbers, so we're going to make that negative infinity to infinity, because that's how we've been doing interval notation. We'll be consistent. Okay, and then zeros. Once again, I have an infinite amount of zeros. But how often do they happen? Every pi. They happen every pi, and I'm starting at 0, which means I can say that it's just n times pi, and then I would say where n is an element of the integers. All right, what's my y-intercept? 0, 0. Okay, and then on this one, we do have asymptotes, right? And we have a lot of them. And so we have to, but just like with rationals, remember with rationals, what our domain couldn't be is what our asymptotes were. So we've already really defined what our asymptotes are, because that's what the domain can't be. So where this says x can't be this, our asymptotes are x does equal pi halves plus n times pi, where n is an element of the integers. Okay. It's important to me that you see this kind of notation because it is correct math notation. It is stuff that you would see, you know, in the future and be able to connect all this stuff together. All right, so what do you think about the amplitude? Well, the amplitude, remember, it's half the distance between the max and the min values. Do I even have max and min values here? No. So if I don't have max and min, I can't find half the distance between them, right? So those are undefined. We do not have one. Most of the time on tangent, you won't be asked for the amplitude, but if you are, you just put that it's undefined. Okay? We still have to kind of think about the amplitude type thing. I'll talk about that in a minute, but it's not actually defined. All right, then what's the period? Pi. Okay? It repeats every pi, because if I start here, right, I do this, I have this, and then it starts to repeat right here. So the period is pi. For sine and cosine, it is 2 pi. For tangent, it is pi. And that is one of the biggest mistakes people make when we start graphing all of this stuff, is just getting the periods incorrect. So just remember that tangent is different than sine and cosine. So the period is only pi. We good? All right, so for sine and cosine, we left this whole thing blank for now. We're going to come over here and fill a little bit of this in, but not all of it. We're just going to talk about the amplitude and the period over here, because we just said that the amplitude's undefined. So I want you to draw a little dotted line right here, and we're going to write undefined right here. However, our amplitude for sine and cosine came from the a that's multiplied out front when you have transformations. So we could still have an a times the tangent of x, right? That a, before we talked about amplitude, what does a do for every other graph you've ever graphed? Vertical stretch or compression, right? And that's the same thing here, because we can still stretch this thing, it's just not called the amplitude. So this could be a vertical stretch or compression, and that's just the absolute value of a. Just like it has been for every other graph before we got to sine and cosine, okay? Then the period, no, it's the definition of the word amplitude. Like there's still a stretch, but the amplitude is half the distance between the max and the min. And since you don't have a max and min, we just can't call it amplitude. No, there is a number. It's just not called the amplitude. It doesn't have a name. A number doesn't make it undefined. The definition of amplitude is what makes it undefined. Okay? Period. So the period for the parent function is pi. That b is still the horizontal stretch and compression. So the period for any of the functions is pi divided by the absolute value of b. And then we'll fill in the rest of that. That's all too much to do on the first day with all this stuff. Okay, we good? Now promise me you're not going to be freaking out over things like this. Like you got to let that go so it's not, you know, I'm not asking you those questions on the homework. Just need to see it in the notes. Yes, sir. Transformations that we've been doing for years. The vertical stretch and compression in front, the number in front. You'll see in just a second. All right, then this, so let's look at this one. This is going to go on page 102. We'll look at all that again. So the tangent function is undefined for certain values of x. Therefore, the tangent function has vertical asymptotes. We've already looked at those. But on this little picture, I don't know if it's because of the way it's copied or if maybe they weren't even there and I didn't notice it. They're not there, and we don't need to regraph the whole thing. Just go in here and draw in the asymptotes because they are something that needs to be in there. Right. And then tangent function does not have an amplitude. Okay. So we're going to look at the two minor transformations, just the stretches here. So if f of x equals a times the tangent of bx, so there's your a and b. The period, we just talked about that. It's pi divided by the absolute value of b. And then I'm going to define where the asymptotes are. I mean, it is true that this is what they are. That's not how we're ever really going to have to look at them or figure them out, though, so I just want to make sure you get that. The asymptotes are the odd multiples of pi divided by 2 times the absolute value of b. So that's just kind of defines where they are. They don't happen every pi halves. There's every other one. Okay, but this period is really what we're looking at here. Okay. So we're going to go through and graph these, and just like I said on the other ones, if you're actually doing what I tell you to do, this is really not that big of a deal at all. So for the other ones, you had it said amplitude right here with a question. And so if it did say that, I'd put undefined, but I do still there's still a number here. So that number is actually my vertical stretch, and that's 4, something I still have to take into account, right? What would the period of this be? Pi. Okay. Then I'm going to draw in my parent function. So one cycle of the parent function looks like this. That's one cycle of tangent. Okay. And that still gives me basically 5 anchor points. I have the zeros here, the asymptote that I could count as 1, and then this point here, which in the parent function, that's at 1, right? It's at pi force 1. And this is at -1. So those are my 5 pieces that I got to get put on here. Because there's no translations left, right, up, or down, since it starts at 0, 0, the stretches don't affect the 0, 0. So I'm still here. So that's this point. Period is pi, so I put the other 0 at pi. So now I have this. Then the asymptote goes halfway in between those. All right, so got the asymptote taken care of. And then halfway in between this first 0 and the asymptote is going to be that other point, which on the parent function is 1, but I have a stretch of 4, so I actually go to 4. And then halfway between these two, I would be where? -4. And before you start to repeat this, after you get your 5 things, double check yourself, because here's where some other places where people are going wrong. I've seen a lot of people have the correct period written down for sine, cosine, and tangent, but that's not the period they graphed. So I put pi. I'm going to make sure that one cycle only goes from 0 to pi. Make sense? Otherwise, it was too, whatever, I messed up somewhere. So now that we have this, is this enough for you to be able to duplicate it? Yes, I got zeros at every pi, so that's what I would start with. Then I would go through and put in all my asymptotes. You can do it in whatever order makes sense to you. Just make sure you're paying attention to the actual pattern and the spaces between things. Yes. Okay. And make sure you got arrows. Make sure that you're actually taking the points all the way to as far as you can on either edge, and you actually complete the graph. Okay? We good? What questions do you have? All right, let's look at number 12. Okay, so number 12, do I have a vertical stretch or compression? No, but I do have this negative, which means I'm going to have a reflection in the x, right? And then what is the period? 2 pi. It's 2 pi because it's pi divided by 1/2. All right, so then I draw in one cycle here, starting at 0, 0, so I'm at 0, 0. The end of the period is at 2 pi. So I now have these 2 points plotted. There you go, halfway between. I'm going to put an asymptote. And then halfway between 0 and pi, which is at pi halves, I would be at 1, except there's a reflection, so I'm at -1. And then halfway between pi and 2 pi, which is 3 pi halves, I would be at -1, but I'm at 1. So there's my one cycle through 2 pi there. Okay. All right, so then we duplicate that. I have zeros every 2 pi. And then can I put another point on the left or right of 2 pi's? No, because I'd have to skip one. So that's it. All right, we good? Yes. All right, I'm going to do one more together. All right, number 13. Do I have a vertical stretch or compression? Yes. Which one is it? Stretch. It's a vertical stretch of 5 halves. Do I have a reflection? No. What's the period? Pi halves. This one is pi halves. Okay. And then parent function looks like this. Okay. So start at 0, 0. The end of the period is at pi halves. So I have the beginning and I have the end. Halfway in between those, I put an asymptote. And the asymptote is at pi fourths. So halfway in between those two at pi eighths, my parent function's at 1, but I have a vertical stretch of 5 halves, so I'm really at 2.5 right there. And then halfway in between these two, I go to -2.5. And so there's one cycle through pi halves. Okay? So every other point is a 0, and I can go finish that off. Remember, this is not an art class, but you do have to hit the points. You do have to have arrows. You do have to make an attempt to make it look decent. Okay? So what questions do we have? All right, so then once you have completed this one, if you don't have any questions, you do number 14, and once you can show me that those are done correctly, then I will give you your assignment.